Welcome back to PA Academy. So this is the third example we are going to be looking at under divergence of a vector and another example under solenoid vector. So the question says determine the constant f so that the vector is solenoid. So here is a function. So f is equals to x plus 3yi plus y minus 2zj plus x plus bzk. So this is the function and you are going to check, we are looking for the value of f considering the fact that this vector is solenoid. Alright, so let's do this. Alright, so again, let's establish the formula for a divergence of a vector. Exactly. And again, now the question did not even tell us that if it is a divergence or not, but for the fact that the question has mentioned solenoid. Exactly. So for it to have mentioned solenoid, that's an indication. So that's another thing you need to pay attention to. The question might not tell you if it is divergence or not, but once you see solenoid, you should know that they are talking about divergence. So for us to do that, let's write out the formula for divergence. So what we are going to be having is, so of f will be equals to, so the partial differentiation of a partial fraction of x, then I plus, so let me just quickly write this. Then for that of z, so all of this in brackets with the dot product of the function of f itself, so which is x plus 3y I plus y minus 2z j plus x plus bz k. Are we good? So now we can go ahead and multiply. So let's just do that, because actually in solenoid all of this from here to here will actually equals to 0, but let's still leave that step till we to the next two steps. So now what we are going to do is, so this will come and multiply this, and then the j coordinates will go and multiply the other j coordinates, and then the k also will go and multiply the k coordinates. All right, so with that we are going to be having the partial differentiation over partial differentiation of x multiplies this is multiplying this. So I'm just writing out everything because I don't want to miss any step so that I don't just get confused. Then don't forget, I said once they are multiplying each other, the coordinates will no longer be there, the I and the j and the k. So plus partial differentiation over partial differentiation of y multiplied by y minus 2z plus, this is z, that will be x plus bz. Are we good? So let's do this. So if I should differentiate in this, it just partial differentiation with respect to that of x, so we are going to be getting, so for this now it's going to give us x. So we don't have any business with this. This will just assume it to be 0 because there's no x attached to it. So plus, so let's look at partial differentiation of this. This is y, so if we differentiate y, it's going to give us 1. So plus 1, we can't have any business here because there's no y attached to it. Then plus, now for this is z. For this, if you can't, this will be 0. And then if you should differentiate this bz, it's going to give us b, because b is just the constant there. Is that good? So that means our div of b is giving us x plus 1 plus b. Sorry, this is 1, sorry. So this is 1, not x, because if you differentiate x, it's going to give us 1, not x. Exactly, so this will be 2b, sorry, so this will be 2 plus b. Now, from the question, it says it's is a solenoid vector, and from solenoid vector, we've already understand or established the fact that for a solenoid vector is up equals to 0. Exactly. So that means what we are having here is supposed to give us equals to 0. So that means div of b is equals to is equals to 0, and then 2 plus b equals to 0. Exactly. So we can just conclude that our b is equals to minus 2. So this is actually the answer. So let me just do a little modification here. So from the question, this is, let's take the function back to b. So let's just indicate the function as b, so that every audio b that I've written here will just be the same thing. I can't start correcting that, or editing it. So that's it on this question. Let me just return this back to b. So the solution is still correct, everything is still correct. I was just trying to modify some alphabets, exactly, but let's just leave it like that. So this solution on it, we've been asked to determine the constant b, so that the vector solenoid b is this. So the basic thing you just need to understand here is that once you say a vector is a solenoid, just understand that your div of that particular vector is equals to 0. Exactly. So whatever you get, if you are getting an answer that is not equals to 0, maybe for just like in this case, we've got our answer to be our div b to be equals to 2 plus b. Exactly. So that means this b is actually a value that will make our div b to be 0. So you can just go ahead and equate it as 2b, as 2 plus b equals to 0, so that you can get your value of b. So that means our b is minus 2. So if we bring in this minus 2 into this, so we are going to be having div b is equals to 2 minus 2, and that will give us 0, which has established the fact from the question that it is a solenoid vector. So I hope you get that. So that is it on this particular examples, and this lecture series continues in the next video, still under call, divergence, and gradients. Thank you.